Okay, the last example, I think, which is about formatting data in a viewport, which is also a very useful feature, which is, well, it's not impossible, but it's difficult in Rhino itself, and usually quite intensive in terms of manual labor. What we'll do here is we'll take a shape and we'll slice it at different heights, and at those elevations, we'll find the floor area of that building. And once we have the floor area, we can format the area, meaning round it to a specific number of decimal places, and make it nice to actually look at, so we can add meters square to it, and display this text in the viewport at the middle of the floor. And we'll even use the tools to actually calculate the total area and display that value as well in the viewport. Because colors are nice to look at, but when you actually need numbers, it's better to have text in the viewport than numbers. So we have a building of sorts. It's a bit of a weird shape. As you can see, it's going to be quite difficult to get a feeling for areas on the shape of a building like this, because you just can't sense it. It's beyond your capacity as a human being to actually see this building for what it is. So what we'll do is we'll import a building and generate a bunch of floor plate sections. The importing is easy. We'll use a BREP parameter. BREP is an abbreviation that stands for boundary representation, or a polysurface, as you may know it from Rhino itself. So the tooltip actually says polysurfaces, and a BREP basically means that you can have any number of joined surfaces and trimmed surfaces together in one place. So we have one BREP. We'll assign it this object. We will hide the preview. Sorry, hide the building, and we'll generate floor sections at different heights. Now, how I define the height of each floor is a bit of a question, of course. I might have a list of floor heights. For example, I might have a text panel and say, well, the first floor is at 5 meters, then 10 meters, then 15, then 20, and then we get lower floors, and we get 23, 26, 29, 32, and so on and so forth. So I can actually have these numbers as constants defined in a text panel. And this will allow me to generate a bunch of points at those elevations. So if I go to the vector panel, I can make points from x, y, and z coordinates. And I can overwrite a z coordinate. And you will actually see here that there's all these points generated from my numbers. In fact, it would be even easier if I hide this preview. Okay. So we have 5, 10, 15, 20, 23, 26, 29, 32. Different way would be to actually generate a sequence of points that have a constant distance between them. So I can use a series component to actually generate these numbers from scratch. So by default, a series component generates from numbers between 0 and 10, and steps as 1. And we can say, well, we'd like to start at a height of 3 meters. That's going to be our first floor. And our floors are 4 meters in height, so that's going to be a 4. And we'll have at least 50 floors in this building. I mean, probably less, but we can go higher than that. So now we have a list of numbers, starting at 3, steps of 4, and a total of 50 numbers in this list. And by feeding this into the Z input, you can see all those points. And clearly we have way too many. In fact, we have so many too many that we can just go back to, say, 25 or something. That's better. So here we have points in space at elevations controlled by a expression. We have a shape imported, and we now need to make actually floor plates at these points. As we've seen before, if you have points and you want planes, there is a default conversion between those two. So I can take a plane parameter actually share these points, and it will generate those little plane objects at every single point location. So these are now my floor sections, and I can actually use those inside the BREP section component, which you'll find in the Intersect tab. There's a BREP plane intersector, which takes a shape, takes a plane, and actually gives you the outlines of that object. So let's hide the shape and the grid, and let's move. So here you can see. So here we have for every single floor plate an outline, which is sometimes quite complicated. There's little nooks and crannies and weird curves in this outline. So it's very hard to see which floors are bigger, which are smaller. Okay. Let's hide the planes. We don't need to see those. And let's measure the area of all these sections here. So if I search for the word area, we have BREP area. And once again, we have curves here as the outline, and we need polysurfaces to measure the area. But if we share them, it works fine because a closed planar curve, should have, well, that's interesting, should have converted fine to a BREP. However, it failed in 2 accounts, and I'm not sure why. Let's have a look here. Apparently there is a weird, apparently we slice this building in a way where exactly where this roof here happens, and the intersection curve is not closed, so it can't make a single closed face out of this thing. We could fix this, but let's just cheat for now and actually change the elevation of the floors, so we can start at 3 meters with 3.5 meters, and this should actually get rid of that problem for now. So now we have proper outlines, and this intersection is correct everywhere. This is obviously not an actual solution, but it's just to keep things moving along here. So when we have the area and the centroid, we can see for every floor the point where the area is the centroid of the area. And we have a bunch of numbers for every floor. So we can take this and have a look at this. What you'll see here is that there's a lot of accuracy in this area, and probably much more than we can expect to have. So we need to round these numbers to 2 decimal places, or maybe even just 1 decimal place. And we need to append the little meter square symbol so we can actually know what we're looking at. But before we format this information, let's display it in the viewport using a point tag. So in vector point, you will find a text tag 3D component, which has 3 inputs and no outputs. So it's a bit of a unique case because it doesn't actually generate data. It only displays things in the viewport. Now our location is the centroid of the floor, and the actual text we want to display is the area of the floor. And the size is just default 1. We can hide these points, preview off. And now if we zoom in, you can see that there is floor numbers shown inside every floor area. Okay. So there's a question about where I found the area and the tag. I found the area by just searching for the word area in the search list. But it will be inside the Surface Analysis tab. There is area and volume as 2 of those components. And the text tag, again, you can just double-click and search for tag and pick the one you want. But it's in vector point. At the bottom here, there's 3 components that actually show stuff in the viewport based on points and strings, points and text. Okay. So this is already halfway there, but we still need to round the numbers and put a nice little meter square symbol behind them. And we can do this with an expression. This is where it gets a bit finicky. I will use an expression for one variable, so that's fx1. And this thing takes a single thing. It could be a number, it could be a point, it could be a piece of text, and it will run an expression on that piece of data. And the expression is something that we type in by hand. In this case, it's a formatting operation. And the way this works is a bit complicated. But there's a function called format, which takes a formatting text, piece of string, so this is like a mask, and it takes any number of data items. In this case, x is a number. And it will insert this number into the formatting mask at the correct location. So when we have those brackets here, it will take the x and put it in the brackets which have the index 0, because x is the first value we have. If we had multiple ones, if we had x, y, z, then we could have bracket 1 and bracket 2 as well and format x, y, and z. But we have only x, so we have bracket 0. Then behind the colon, we have a rounding pattern. This means we'll allow x to be rounded, to be displayed to 2 decimal places. And finally, we just have a literal constant, just a text, meter squared, which will be appended to our formatting. And when we do this, you can see that it actually overrides the display here. It now rounds to 2 numbers and displays meter squared at the end here. I can change this easily. I can say this is, maybe it's not meter squared, maybe it's square foot. Or maybe it's floor area. So this is all quite flexible. It's, I can even change the display. I can remove the decimals altogether and just go to a single number without decimal points. Or I can say, well, I'd like to display 1 decimal point at least, but if you have more, I will accept 2 more. So these are all quite accurate numbers, so they all display 3, except for this one over here, which apparently was rounded to just 2 decimal places. There is an incredible amount of possible ways to define this formatting. And it's online information. You can find it. And you can format numbers, you can format dates and times, you can format currencies, you can format all kinds of stuff. So you could even have a display for how expensive it would actually be to rent out this floor. All that kind of stuff is possible. Okay, there was one more thing to do. It was to calculate the average, the total of all the floors together and display that in a separate text tag. Now, this actually gives us a bit of a problem because we don't have a single list of all the floor areas. What we have is a very complicated data structure that has all the areas but stored in a very, very complex way. When you slice the graph with a